Okay, so we are doing the module lesson 4.1 skill check, and we're doing this with period 3, math 8 class. So if you hear some people talking, it's the math 8 students in period 3. We're going to go through this and review it for some makeup credit. Sound good?
Yep.
Okay, so what we have is we have this real world scenario here, and it's talking about pizza. A large pizza costs $10. Each topping costs an additional $2. This situation can be represented by the equation y equals 10 plus 2x, where x represents the number of toppings and y represents the total cost. So this is a real world scenario, and this is something that you guys want to pay attention to, because in life you will have things that have a down payment and then have like a monthly or reoccurring cost. And that can be represented by this equation. So how many of you guys have cell phones? Those of you guys listening can't see it, but most of the class has cell phones. How many of you guys pay for your own cell phone? You do? Okay. So how many of you guys know what your cell phone costs, what your cell phone plan costs? So no matter how much data you use or how many minutes you use, it still costs money per month, right? And then if you go over, sometimes it costs extra money per minutes or per gigs, right? So that is represented by an equation like this, where you have an initial value and then you have price per unit, your unit rate of something. So in this case, no matter how much toppings you get, the pizza still costs something itself. So if you got 0 toppings, how much would the pizza cost? Which is what? $10. So if you have 0 toppings, the pizza still cost $10. And so some of you guys made an error here because you didn't set your table up correctly, but it gave us the values here in it, where x is the number of toppings and y is the total cost. Okay, so it gave us that information in the equation. So if you guys made an error on your table, even if you did the rest of it correct, it wouldn't be accurate. Does that make sense? Okay, so using this equation, we can plug in any number of toppings and figure out how much the pizza is going to cost, right? So if we have 1 topping, I'm going to plug that value in here, right? 1 times 2 is 2, plus 10 is, so a pizza with 1 topping costs how much? How much does a pizza with 2 toppings cost? 14. How much does a pizza with 4 toppings cost? Oh, I tricked you. 18, right? And how much is a pizza with a bunch of toppings, like 6? How much would 6? 2 times 6 is 12, plus 10 is 12 plus 10 is 22. We got it. Okay, did you have to use these values on top here? No, you did not, but you do want to pick values that make sense to the scenario, right? To the situation. There's a question in your homework a few nights back where it says, how do you choose X values for a table? You choose values that make sense to the situation. These numbers make sense for toppings. Would you want to pick like 10, 20, 30, 40 if you're talking about pizza toppings? Probably not. I don't know many pizza places that will let you have 10, 20, 30, 40 toppings, right? So you're going to pick numbers that make sense. Okay. So our table is complete. Any questions on the table? Are we feeling okay, better about it? All right. So we have a graph now. And setting up the graph, guys, this is always going to be a y. This is always going to be x. So some of us made that error, and that was the first error we made. This is always going to be the y-axis. This is always going to be the x-axis. And we know what y represents because they gave it to us in our scenario, and it's in our table also. So what does our y represent? Y represents the total cost. So we're going to label this here. Whoops. Not dollars. Total cost. Okay, and what does it make sense to count by on here? Would it make sense to count by 1, 2s? Okay, well that we don't want to start here at 10. We can't do that because that means that we'd have to count by 10, 20, 30, 40, 50. Each unit needs to have the same value here. So we probably want to start with something like 2, right? And that's a nice thing to use because our cost per topping is 2. So that's going to make things line up really nicely. So 2, 4, 6, 8. Okay. And then what is my x-axis going to be here? What's that going to represent? Yeah, my number of toppings. We got that from our scenario, from our information here, and from our table. So this is our number of toppings. And what values make sense to put in here for our number of toppings? What do we want to count by? Ones, probably. We don't go any higher on our table than 10. We could count by 2s, but we're probably not going to put 20 toppings on a pizza, right? So again, we want to pick values that make sense. These don't have to be the same. X-axis does not have to be the same units as Y-axis, but the units within that axis need to be the same. You guys following so far? Is it making more sense? Okay. So where is my first point going to be? These are my ordered pairs, right? So 0, 10, 1, 12. I'm just rewriting these. You guys don't have to rewrite these, but some people, it makes, when they can see them in a different format, it makes more sense for graphing. So you don't have to do this, but I'm going to. But I'm just pulling these points from the table, right? You guys see that? I'm just getting these points from the table. Okay, so some of you already said my first point is going to be at x is 0 and y is 10. Because a pizza with 0 toppings still costs $10. Do you guys remember what we call this point here? This is our y-intercept. In our equation y equals mx plus b, it's b. So in this case, b equals 10. Yeah, it's when x is 0, y is 10. From there, our equation y equals mx plus b, where b is our initial value and m is our slope. This is backwards. They did b plus mx, and you can do that. That's fine. Right here. That represents our b, and this represents our m. They flip-flopped them in this equation, but that's okay. They can do that. And then I'm just going to go ahead and plot my other points here. One topping pizza costs $12. 2 toppings costs 14. 3 costs 16. 4 costs 18. 5 costs 20. Okay? So how many of you guys were on the right track? You're on the right track? How many of you guys were not on the right track, but it makes sense now? Good. I'm just going to scroll down a little bit, and we're going to look at question number 3. I'll leave the graph up there. So question 3 is asking, explain why this relationship is not proportional. Why is it not? How many of you guys think that this is a proportional relationship? How many of you guys think that is not a proportional relationship? Well, it's asking you why it's not, so it's telling you that it's not a proportional relationship, but why? What do you think, Michelle? Yeah, exactly, because it doesn't start at 0. So what that means is that even though, how many of you guys are like, well, it's a straight line, it should be proportional? That's a common error. What a lot of people did is, you guys said, well, it's a straight line, so it should be proportional. But a straight line and a proportional relationship are not the same thing. A straight line is called a linear relationship, and that means that your rate of change or your slope is the same. It's constant. That is not the same thing as proportional. Proportional means it starts at 0. And in this scenario, for this to be proportional, it would have to be that your pizza costs nothing and you're only paying for toppings, right? But because we have an initial value of $10, an initial cost of $10, it's not proportional. It does not start at the origin. And so This is a linear, non-proportional relationship. If it doesn't start at the origin, it is not proportional. If it has an initial fee or an initial cost, it is not proportional. You guys following? Okay. So I'm just going to give you a quick answer here. I'm just going to write down not proportional or non-proportional because it does not go through the origin. Which is our 0, 0 value. Also, you could put something like because a pizza with no toppings still costs $10, or there's an initial fee of $10. Okay. How are we doing? Okay. Some light bulbs coming on for some of us? Cool. Cool, cool, cool. So this last question here, a lot of you guys, some of you guys did really well until you got to question 4, and then you're like, I don't know what's going on. So I didn't actually count question 4 against you. I counted it as a bonus credit. So if you got it right, it was bonus. And question 4 is, does it make sense to connect the points on the graph with a solid line? How many of you guys think, yes, it makes sense to connect the points? How many of you guys think, no, it does not make sense to connect the points? Okay. In this case, it does not make sense to connect the points because you can't buy 3/4 of a topping. You can't buy part of a topping. And that's represented by the space in between the points would be our parts of our topping. Since you can't buy part of a topping, you're not going to connect the points. Are there scenarios where you would connect the lines in a real world scenario? Yeah. If this was like a distance over time type thing where you were measuring distance and time, absolutely it makes sense because you can get a distance at any point in time. But in this case, we can't get 3/4 of a topping. So we're not going to create a value in between here by connecting it. Does that make sense? That's higher order thinking. It's a real world situation. Now that we've talked about it, expect something like that to be on a quiz. Okay. So I'm just going to go ahead and answer this. Does not make sense because... Yeah.
Unless they cut the pizza and then you got half on the side.
Okay. Well, we're going to say in general you can't buy right? You can't buy part of a topping. So that is the rundown on lesson 4.1 skill check. If you want to submit this for some correction points or some redo points, go ahead, put redo on the top or put corrections on the top. Circle your new information, leave your old stuff, circle your new stuff. If you were absent, write absent on it. If you got full credit or if you got enough credit that you don't feel like you need to resubmit it, then just keep it. Any questions? Are we good? Okay, I'm going to go ahead and stop recording then. And you guys want to say anything on the video? Want proof that you were there? Go ahead. I don't know if it'll pick you up, but go ahead and...
Just scream potato.
Those of you listening, you can stop the video at any time.
Potato!
Pineapple 7.
Pineapple 7.
If it gets you guys to listen to the video, you can say... All right.